So as you check out this number 1 on the simplifying radicals page, we're going to start with the square root of 32. Now, one thing I like to do, like I wouldn't do it with 32, but I think it's a good skill, is to do prime factorization. I'll show you what I mean by that in a second here. I want to also point out what we're going to be looking for here are perfect squares, because we can square root perfect squares. So we're going to be looking for factors of 4, 9, 16, 25, 36, 49, 64, and so on. Okay? Because I can take the square root of those things. So as I'm looking at 32, do any perfect squares come to mind for anybody? 4. Okay, so let's say I could see that. A 4 times 8, right? Now, let's also look at the 8. Are there any perfect square factors of 8? 4. So this is a factor tree, and it's just one way I like to visualize like what is making up my number. So would you guys all agree that 4 times 4 times 2 would be 32? Okay, so see these two factors of 4 right here? That's actually a factor of 16. So this factor tree is just a strategy. It's not the math. It's one way I like to visualize what's making up a number. Okay? So I've got a 16 times 2 there. Everybody see 16 times 2 is the square root of 32? Square root of 16 times 2. Now, here's the reason why I'm trying to get that 16. It's because I can take the square root of that. So this, again, is just organization. I like to circle it. And that 16 saying, hey, man, cash me outside as a 4. And here is my simplified square root. So 4 square roots of 2 is square root of 32. It's just the simplified version.
Wait, but why is the 4 outside?
Because I took the square root of 16. Square root of 16 is 4. So that can come out. 2 has to stay underneath by itself. 4's probably out here talking all kinds of smack, but what 4 doesn't know is 2's up in there with some Mountain Dew Code Red in the video games, okay? So he's alone, but he's not alone.
Here's a house.
Isn't it easier to just skip the first thing you did and just write 16 times 2 and then move the 4 out?
Okay, so yes, that might be easier if you just see that with 32. Like I would just see that. But some people might need to see how 32 is made up to be able to decide. But really, we're looking for 4, 9, 16, 25, 36, 49, ... We're looking for those perfect squares. We need factors that are perfect squares to simplify. Okay, so let's look at number 3 next on your sheet. I've got square root of 125. So we can do that. Anybody have any ideas of a perfect square I could divide this by, that, or a factor that's a perfect square, Nate?
25 times 5.
25 times 5. So I always rewrite it like this, 25 times 5. Or some people like to write it as the square root of 5 squared times 5. It's the same thing. Either way, when I pull this outside, what does it become? 5 square roots of 5. Now let me show you what happens. What do you notice about this one when you pull it out? Square roots undo squares, right? It's the same thing. Whatever way you want to think of it. Okay? Now you can check this in your calculator. Type this in your calculator, type this in your calculator. It'll pump out that same decimal. That should be something like 11 point some junk. Okay? Miles?
What's the point of that if you still don't get like a rational number?
Well, the point of this is the exact answer, which is an irrational number that keeps going. So you'll see when we do some computation with the next class, you can kind of treat your square root of 5 like a variable a little bit. But the point is, if you do like multiple computations of multiples of these are all exact answers you're using versus rounded. Good question. So remember I said you might need some help like figuring out how something's made up? Let's look at number 7. Are you guys noticing number 7 is one you're like less likely to be like, oh yeah, boom, it's got a factor of this? Okay, so this is where I like that prime factorization, okay? Or just factors, like breaking it down into factors. So one way I could do it is I notice it's divisible by 2. So 2 times 192, right? Okay, and I circle that 2 saying that's prime. 192 also divisible by 2? 2 times 96, okay. 96 also divisible by 2? 2 times 48, divisible by 2, 24, divisible by 2, 12, divisible by 2, 6, divisible by 2, 3. I almost ran out of space. Okay, so that's a lot going on, but this is the build up of the smallest numbers. Now, two 2's together make a factor of what? 4. So I've got 1 factor of 4, 2 factors of 4, 3 factors of 4. So 3 factors of 4 would be how much total? 64, right?
Oh my god.
All those circled factors are 64.
Wait.
4 times 4 times 4.
Why did you ignore the last one? The last 0.
Well, because it is a factor of 6 that's left. So again, this is not like a requirement. You could sit there in your calculator over and over and divide by perfect squares and see which works. That works. But I like to think about how a number's made up. And then I use that. You know, I use like the little Lego pieces to build the bigger one.
Wait. Why do you not? Why does the 2 stay the same again? Because the
What?
3.
Well, it's not a perfect square factor, right? I got a 4 times 4 times 4 times 2 times 3. Well, this 4 times 4 times 4 is a 64 factor, which is nice because I can take the square root of 64. All I did was I broke down my number into its smallest parts and reassembled to find my perfect squares. Again, it's a strategy, it's not the math. This right here, this is the math. I need to know that 384 has a factor of 64 and 6. And the reason I need to know that is this 64 right here can be like, hey, 6, cash me outside, baby. 8 square roots of 6. Now, you want to look at that 6 and like kind of ask yourself, what are the factors of that 6? 1, 2, 3, and 6, right? None of those are perfect squares, so it has to just chill as 6. Yes?
On the Khan Academy for this, they would write it as 8 squared.
Yeah, 8 squared is 64. So if you want to do that, it's fine. I'm cool with that. 8 squared times 6, that comes out as 8 still, right? Same. Yeah. So when you get those big things, like you don't have to use this over here, all this, that's a strategy. I use it a lot just to see how numbers kind of break down, because then you can reassemble them in different ways to find common factors and stuff. Cool. Let's look at 245 together, and then I'm going to have you try some on your own. Square root of 245. What are some factors we're seeing there, friends?
Is that number?
5.
You're seeing a 5, okay? So let's say we divide it by 5, we get 49. Oh, that's nice. Very nice. So 49 times 5, 49 says, cash me outside, 7 square roots of 5. So again, we're looking for factors that are perfect squares. It is a good day to know your multiplication facts, friends. I don't know if you've noticed, but I haven't touched the calculator yet. And, okay, you think I memorize all these problems?
My anxiety reliever is to grab my
Look
calculator.
at, Nathan, look at what I'm looking at, bro.
Yeah. Do you do different problems for each class?
Yeah, I don't keep track.
Yeah, no.
So whatever I'm vibing with. Okay, I want you guys to try out number 10 yourself,
5 times 5.
and then jump to number 13. 10 and 13, please. So number 10. I had square root of 50. Who can give me the perfect square factor they used? Braden.
2 and 25.
Yeah, 25 times 2. 25 says cash me outside as a 5. 5 square roots of 2 is equivalent to square root of 50.
So, Mr. Mac, do you cash it out once you find the perfect square?
Yeah, you need a factor that's a perfect square.
Okay.
Now, 448. I'm going to show you how I would go about getting... I'm going to guess it's a 64, just because there's lots of 4-looking things there. But instead of doing prime factorization, you could also do like 4, 112, 4 works there. 28, 4 works there. Okay? So do you see how like I found factors? I got 3 factors of 4, which would be 64 times 7. This 64 says cash me outside as an 8.
That's what I did, but on the one where you had the...
8 square roots of 7.
On number 7, you...
Now we're going to put some variables in the mix, okay? And variables, they look scary, but this is actually... Nothing actually is going to be new here, okay? Now, one way I like to think of the square root is Who can tell me what exponent a square root is equivalent to from our exponents unit? A square root is what power?
2.
2 is squaring it, right? Undoing that.
Oh, 1/2.
The 1/2 power. Remember, the denominator of the fraction of the exponent is the root. So this is the same thing as this, correct? To the 1/2 power is the same thing as square root. So watch this. We already know the square root of 9, right? 9 says cash me outside as a 3. Now, one way you can think about this exponent, I just memorized this in school and I didn't understand it. But if you understand it, you don't lose it. I have a 10 to the 1/2, a k to the 10 to the 1/2. When I have a power to a power, what exponent property can I use? You can multiply. So what's half of 10?
5.
Boom. That's the answer. 3k to the 5th.
But 5 times 5 isn't 10.
5 plus 5. It's half of it. 5 to the 10 to the 1/2. Right?
Square root of the exponent.
The square root of k to the 10 is k to the 5th, right? Cool. So, what do you notice is a little different about number 4, though?
It's, you can't divide by 2.
You can't divide it by 2, so watch what I'm going to do. Here's how I'm going to break this guy up. A 4, a 10, an a to the 18th, and an a.
Oh,
So watch what I can do. I then like to circle what can come out. 4 can come out, and a to the 18th can come out. That comes out as 2a to the 9th, square roots of 10a. Notice inside my radical, 10a, there's no perfect squares left as factors. So if you have a variable, what are the only 2 options for what's left under the square root? If you have a variable, what are the only 2 options for under the square root?
0?
Just one, something to the first power, or nothing, right? Because if it's even, you can divide it by 2 because the square root is 1/2 power. If it's odd, you break it up into the highest even exponent times one more factor to get rid of the odd. Does that make sense how I broke it up? Let's do one more together before I set you on your own on this. 5. Square root of 25, x to the 6, y to the 13. So as I break this down, do I need to mess with the 25? Nope. Do I need to mess with x to the 6th? Nope. But y to the 13th, I need to write as a factor of y to the 12th times y. And I can take the square root of everything except that y. So I get 5x cubed y to the 6th square roots of y.
Wait, but is the square root of 6 isn't 3?
No. It's the square root of x to the 6th. That 6 is an exponent. It's not just a 6. So a 6 to the 1/2 power is 3. X to the 6 to the 1/2 power is 3. Right? It's an exponent. It has different properties than just a straight up number. Yeah, they're like little puzzles, right? I think it's fun. Let's have you try number 12 on your own. All right, friends. So the only thing I'm going to change on the inside actually is z. I'm going to change z to the 6. Stay with me. I can take the square root of this. It's 12, right? 12 comes out front, gives me negative 60 out front. X to the 16 comes out front as x to the 8th. Y to the 10th comes out front as y to the 5th. Z to the 6th comes out front as z cubed. Just a square root of z. Yeah, exponents are different than just straight up numbers, right? It's just the exponent, right?
But I think
I did. I multiplied negative 5 times my 12, which is negative 60.